You know, when I told you to get your note packet out. Okay, inverse functions. Nope. To find the inverse function, there's 5 concepts you must know about the inverses. Actually, we're only going to do 4 of them. We are not going to worry about the compositions, the f of g of x and the g of f of x. Okay? We're not going to do that one, so you can scratch that one out. Okay, step 1, to find the inverse, you switch the x and the y. 2, here, by the way, these are the properties of the inverse functions. Okay? 2, the domain and the range switch. Okay? 3, to graph the inverse, you reflect the original, he's not here. You reflect the original graph over the line y equals x. Everybody know what the line y equals x is? Yeah, I don't know. It's too early in the morning for this. If I have a graph, y-axis, x-axis, my y equals x line is the line that goes on a diagonal, like 1, 1, 2, 2, 3, 3, so on and so forth. So it gets reflected over this line. And number 4, the inverse is a function if the original function passes the horizontal line test. Well, Mr. D, there's a typo in there. It says horizontal line test. No, it's not. We talked about the vertical line test, right? Actually, the horizontal line test tests the original function. If it passes the horizontal line test, then its inverse is going to be a function. Okay. Let's go through some examples here, because there's some explaining to do. Okay, to find the inverse, you switch the x and the y, right? Property number 1, we could switch the x and the y. So my x is -2, -1, 0, 1, 2. By the way, is that a function? Why? What's that, Ariana? I see what you're saying. I know what you're getting at. This, by the way, this is a function. You guys were right. But for mainly because there's no x values being repeated. Remember, when we're given a t-chart or a chart, if I have no repeated x values, it is a function. Right, Clayton? Yep. So my x's become my y's. So -2, -1, 0, 1, 2, and then my y's become my x's. My range becomes my domain. 4, 2, 0, -2, -4. Is my inverse, now this is my inverse, because I switched the domain and range. Is my inverse a function? Yes, it is. Good. All right, number 2. Now, we don't have a t-chart here or a chart, but we can find the inverse by switching the x and y still. Okay? For example, all I have to do here is switch the x and the y. So I get x equals 2y minus 4. Here's the tricky part that we did way back in semester 1 and that you did in Algebra 1 that you spent like a week on. You're going to have to solve for y. You have to get y by itself. Isolate y. Okay, how am I going to solve for y here? That's right, add 4. So I get x plus 4 equals 2y. Then I have to divide every term by 2. Okay. So, don't forget there's a 1 in front of the x, right? Right? So I have 1/2 for the coefficient of x. X is in the numerator, so I'm going to pull it out. Plus 4 divided by 2. Now, this is my inverse function. 1/2 x plus 2 is the inverse of 2x minus 4. I'm going to distinguish that by putting a little -1 here to tell me that's the inverse function. Yes. If you don't, you get it wrong. Yeah, I mean, it should. You guys are probably used to having the y first. 1/2 x plus 2, that's fine. No. We can't have a quiz tomorrow. We don't have enough time. The quiz will be Tuesday. All right, number 3. To find the inverse, I'm going to switch the x and the y. Oh, sorry. And then I'm going to solve for y. Wonderful. Negative 2/3 y. Yes, very good. Easiest way to get rid of a fractional coefficient is to multiply by its reciprocal. So that means I'm going to have to multiply this quantity by the reciprocal, correct? Okay. Negative 3/2 times x. Good. Negative 3/2 x. And I got to put it on this side of the equation because I want my y over here, right? Okay. Negative 3/2 times negative 6. Yes. What do you get? Nope. 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 Negative 3/2 times negative 6. Nine. That is my inverse function. So I can put a little -1 there. Ooh, let's do number 5. That looks fun. Okay, switch the x and the y. Oh, somebody stole one of my colors. I don't know what the problem is. Yeah, I put my pens in my pen holder, and yet they just disappear. Solve for y. I switch the x and the y. What? because that's how I find the inverse. Remember, we switched the properties of inverses, the domain and range switch. So I'm switching the x and the y. Okay. All right. So now I got to solve for y. Well, first I'm going to add 4/5 to both sides. Okay. Okay, so I have x plus 4/5 equals 2/5 y. Now what? Well, you can think of it as dividing by 2/5, which is the same thing as multiplying by 5/2. So multiply both sides by 5/2. Okay, so my y, which is now my inverse, right? 5/2 times x. I'll do that one. 5/2 times 4/5. No. Yes, I would. Nope. Two. Okay, easy peasy, right? Easy to find the inverse. Okay, next section. Do you want to do number 4? I don't think so. Let's not do number 4. We got some tricky stuff going on with the squared thing. Okay, number 6. It says the inverse is a function if the original passes that horizontal line test. Okay, they're asking you, would the inverse of these graphs, notice they didn't say graphs of functions, would the inverse of the function's, oh, this is not a function, that's wrong. Would the graphs of the inverse be a function? Well, we have that horizontal line test, right? So let me get a horizontal line. Would this inverse, the inverse, be a function? Well, does my horizontal line cross it at only one point? Yes. So this would, the inverse would be a function. By the way, is this original function a function? No, it's not. So we shouldn't really call it a function. How about number 7? Would the inverse be a function? No. How about number 8? Would its inverse be a function? Thank you. Pretty easy, right? Okay, number 9. By the way, the f of x is just a fancy name of saying what? Y. Find the inverse. See, x equals 2y minus 4, then solve for y. Add 4, add 4. I know, because they think they know how to do it. Shh, quiet. All right, divide every term by 2. Didn't we do this one? Okay, so my y is going to equal 1/2 x, and it's now my inverse function, right? 1/2 x plus 2. Yeah, we did this one. Now, since they gave it to us in function notation, we're going to put it back in function notation, but we're not going to put the f of x, we're going to put the f inverse of x equals 1/2 x plus 2. It's just because some mathematician decided, hey, we need to distinguish these two, so I'm going to put a little minus sign there. Really, it is. Okay, number 10. Okay, so switch the x and y. So I have x equals 5y minus 2. Add 2 to both sides. So I have x plus 2 equals 5y. Divide every term by 5. So the g inverse of x is going to equal 1/5 x plus 2/5. Last one I'm doing. No, 12 we're not going to do. I think I'm missing more colors. Okay, I'm gonna put y in for the f of x just because I want you to see something. Hey, shh, quiet. How can I solve this problem if I put that over 1? Good. So y times x, I'm sorry, I got to switch them. Cross multiply. I have xy equals 4. Then I'm going to divide by x to get y alone. So the y inverse equals 4 over x. Now, do you notice something? Well, we could put it back in function notation. It's no big deal. So the f inverse of x equals 4 over x. Do you notice something? What's my original function? It's the same. Wow. So my inverse, and this is a function, by the way, my inverse function can equal my original function. By the way, all functions like this, you won't even have to do because any 4 over x, any number over x is going to be it's a function like this. So if you switch them, they're still the same function. All right, that's it. I'm done. So this is the last of your thing on a quiz. We can't do well, maybe we should do the quiz tomorrow, huh?
No, you didn't even go over it.
What do you mean? I just went over it. I can give you the review. You want the review? Nah, you can do that on your own.